This is my first video. Um, I'll tell you a little bit about why I'm doing it and how the video is going to go. So I'm a software engineering student at San Jose State. I I am graduating soon, and as a software engineer, we all do this prep leetcode problems. It's a widely spread idea that everybody does leetcode problems before applying to companies. So I'm on the same route. I'll be doing leetcode problems or leetcode problems mainly, and I figured maybe I can just record these videos and figure out and show the process that I go through of solving the problems and figuring out the underlying principle to of the solution. Um, a little bit about me is that I like math. I have pretty decent understanding of math. I like to understand things in a mathematical way. Um, I enjoy crafting solutions and thinking about what's the best way to go about it and really understand what makes the solution works. I feel like this is knowledge that, or I feel like the process of me figuring out the solution is valuable to be able to record how I go about researching the topic and going about my notes and to craft the solution until I get to the final code uh, that satisfies all the test cases and the edge cases. So we'll start right now with uh, a problem that got picked by LeetCode. I picked it randomly. It's called adding two negabinary numbers, and we'll see how we will go about the solution. So I have no idea how the video is going to go. It might take 2 or 3 hours to solve this problem, or it might take 30 minutes. So we'll see. It's a medium problem, and I'll probably leave the link of the problem in the description. So let's get started. So I usually like using JavaScript because that's what I'm familiar with to write the solution. All right, let's read the problem for a little bit. So given two numbers, array 1, array 2, so the numbers are in arrays, I don't know what that means, in base -2, return the result of adding them together. Okay. Each number is given in an array format as an array of zeros and ones. All right, so it's given in like binary format from the most significant bit to least significant bit. So the most significant will be on the left. It will be at index 0. And look here, we're just going about the problem sentence by sentence, trying to understand what I mean. For example, array 1, 1, 0, 1. So what we have so far is I know that this one is the most significant. Represents the number -2, all that. All right, cool. We know this equation from math, from translating binary numbers into decimal form, except that we use 2 instead of -2. So this should look familiar. We only have the powers when we have a 1. So we have index 3 right here, index 2 right here. We don't have a 2 to the power of 1, but we have a 2 to the power of 0 because of this one. A number array in array format is also guaranteed to have no leading zeros, either array equal to array an element 0 or array the first element of an array is equal to 1. So let's read that one more time. A number array in array format is also guaranteed to have no leading zeros. So I think so it's telling me that the array cannot be the number 0 I can't have one element 0 in it, because that just means the binary 0, which is 0 in decimal. And the first element of the array is 1, so I'm not sure if those two conditions should be true or should be false. A number array in array format is also guaranteed to have no leading zeros. Oh, okay, so those... Huh. So I feel like this one should be true. The first element of the array has to be 1. It can't be 0, because that's what no leading zeros mean. And an array of 0 in it is possible. I think that's what it means. We'll see. Return the result of adding array 1, array 2 in the same format as an array of zeros and ones with no leading zeros. Okay, input. We have an example right here. So we have this number, we have this number, we add them, we get this number, and that's the expected output. And here, array 1 is 11, and we'll get to calculate it right now. Array 2 is 5, the output is 16, all right, fine. The length of array is at least 1 and less or equal than 1,000. No leading zeros. And we don't have to be concerned, or we don't have to check if the elements of the array is anything other than 0 and 1. Let's see. All right, we won't open the hint. Okay, let's think about it for a little bit. Let's think about what negative numbers, or how we work with negative numbers, I guess. And I'm gonna take the example right here. I have it on my notepad. I'm gonna start sharing my notepad also. So I'm gonna have, we have array 1 with 1, 1, 1. And we have array 2 with 1, 0, 1. And we're gonna add them together. All right, so we'll go to my notebook right here, and we have the arrays. So let's, again, we're dealing with base -2. So let's take a look at this number. So I know that this is index 0, 1, 2, 3, and 4. But because they said the most significant thing, from most significant bit to least significant bit, that means this bit is most significant. All right, so we'll work with that. That means this bit will get power of 4. So let's calculate this number. That will give us -2 to the power of 4 plus -2 to the power of 3, and go on this way. So 4 all the way to 0, and pretty much all the numbers, because it's all ones. So we should also notice that whenever the power is even, the outcome of performing the power will be always even, because we have an even number of negatives that we multiply. So negative 2 to the power of 4 will give us 16. The power here is odd, so it's going to give us a negative number. So we get negative 8 for this one. For this one, we get a 4. Here we'll get, I erased everything. We'll get a negative 2, and for this one, we'll get a 1. So adding those numbers, we'll get, I like to add the small ones first. So 8, negative 8 and negative 2 is negative 10. And negative 10 plus 5 is negative 5. So the number ends up coming out to 16 minus 5 is 11. So the example was correct. It was 11, and the second number, we'll do it a little faster. So negative 2 to the 2 plus negative 2 to the 1 plus negative 2 to the 0. And that will give us 4 minus 2 plus 1. And that will be I don't know why I'm struggling with doing this problem. All right, so that will give us 3. So now we're adding these numbers, right? So we'll do 11 plus 3, and that will give us the number 14. All right. Then I need to write 14 in the same form they gave it to me. How can I write 14 in the same form? So I guess we got to remember how we take a normal decimal number and convert it to binary. And the way we normally do that is by just dividing by 2 and looking at the remainder. If there is a remainder, it's a 1. If there isn't a remainder, it's 0. But now we have a different base. So I'm going to try to take the 14 and divide it by negative 2 multiple times until I come up with a binary number. And I'm going to see if the binary of the 14 by dividing by 2 results in the binary result that they had in LeetCode. So here's what I'm going to do. I have negative 2 as the base, and I have 14, and I'm going to start this way. 14 divided by negative 2 is negative 7, and we get 14. And again, here I actually care about the remainder. So 14 divided by negative 2, or 14 remainder of negative 2 is 0. Then I have a negative 7, I want to say, because this was a negative number. Then negative 7 divided by negative 2, and I need to look for the remainder, so that's 1, and I have 3, not 3. Yeah, 3. And a remainder, negative 2, and we get a remainder of 1, but since we're divided by a negative number, we have negative 1 right here, and I need to divide it by negative 1 again. I get a remainder of 1. So this number better be something close to 14. So I have 1, 1, 1, 0. And remember, if you noticed, I'm writing the number this way. This is being most significant number. Let's see if this number actually comes out to be 14. So we have the power 0, 1, 2, 3. So negative 2, 3 plus negative 2, 2 plus negative 2, 1 plus negative 2, 0. Here I get a negative 8. And here I get a 4. Here I get a negative 2. And here I get a 1. So negative 4 plus 4 is negative 4. Minus 2 is negative 6. Plus 1 is negative 5. So this did not come out to be 14. So this is absolutely wrong. Let's see their solution one more time. All right, so it looks like we had a mistake in 101. So part of what's good about this is that you guys make the mistake with me, and if you notice a mistake, you actually made a mistake. So the next time you go through such process, you know the possible mistake you can make, and you'll hopefully be able to avoid it. So we made a mistake with array 2 right here. And the way we interpreted array 2 was 4 minus 2 plus 1. How is that a problem? Array 2 is supposed to equal 5. So this was, oh, that's the problem. So this should not exist. As a result, we get 5 right here. Then 11 plus 5 is 16. So we have to do the math again. To come up with the array. So we'll do it one more time. 16, negative 2, I get a remainder of 0. And I'll put it down as a negative 8 because I'm dividing by a negative number. So the result of that division will be negative 8. And I'm dividing by another negative number. I get a 0 right here. And I put it as a 4. Then, what's the addition? 16, yeah, 16. Then 4 divided by negative 2, I get a 0. And I have a negative 2 right here. Divided by negative 2, I'll get a remainder of 0. And what's left right here is the 1. Divided by negative 2, I'll get a 1. So that's my binary number right here. And I'm going to write it in the array format. Again, most sig right here. So my array becomes 1, 0, 0, 0, 0. And if I want to translate this number to decimal, I have 0, power of 0, power of 1, 2, 3, and 4. and I have negative 2 to the power of 4 equals 16. That's the number that I got. That means this division is correct. So the same way that we calculate, well, so far we don't know yet. Well, let's see if it works on different examples. So the same way we come up with binary numbers for base 2, it works for negative bases as long as we account for this small negatives that come up here and here. Okay, so let's check our answer. We get 1 4 zeros. Okay, this looks good so far. Now, let's try a different example just to understand more of how this division is working. All right, let's say I have, I'm just going to start with numbers and try to come up with the, What I want to do next is figure out if there is any relationship between, or if I might be able to skip if I'm able to skip this work and this work and be able just to look at the arrays maybe and figure out if I can get this array from these arrays directly without actually translating them to decimal. But I want to also do another example just to understand it a little better. So I'm just going to write a random example from my head. So I'm going to have 1 1 1 0. Now I'm going to have 1 1 1. And I'm going to try to keep decimal on the right side and the binary on the left side. And again, here we're working with base negative 2. So for this one, I will get power of 0, power of 1, power of 2, power of 3, power of 4. So I get negative 4 to the power of 4. I don't have a power of 3. I have a power of 2. And I have a power of 1. And that will give me, I'll do the math a little quicker, 16 plus 4. I'll just write it here. 16, and I have a 4 right here, and I have a 1. Oh, this one is a negative 2, so I get 18. And for this one, I have negative 2 to the power of 2 plus negative 2 to the power of 1 plus negative 2 to the power of 0. That will give me a 4 right here, that will give me a negative 2, and that will give me a 1. So these will equal to 3. So the decimal number that I should calculate, or the sum that we get, is 21. All right. So I want to write back 21 in the binary form, in the, I think they called it Negabinary. Negabinary. And I think that stands for negative binary or something. So I'll do the division pretty quickly. So I have 21, looking for the remainder by dividing by negative 2. I'm going to get a 1, and I am going to get 10. And I'm going to get a negative 10. Divided by negative 2, I'll get a 0, and I'll get a 5. And dividing the 5 by negative 2, I'll get a remainder of 1, and I'll get a negative 2 right here. Divided by negative 2, I'll get a remainder of 0, and I'll get a 1 right here. Then for this one, I'm dividing by negative 2, and I'll get a remainder of 1. I got my array, so the result that will come out from this side is equal to 1 0 1 0 1. To look at this and see if we actually get 21. So that will give us, this is the power of 0. 1, 2, 3, 4. So I'll get -2 of power of 4 plus -2 of power of 2 plus -2 of power of 0. And power of 2 of power of 4, that will give me 16 plus 4 plus 1, and that will give me 21. So the math here is correct. And this is the array that I got right here. I want to see if there is a relationship between this one and this one without doing this work, because I might be able to do my code to transfer everything to come up with the code to transfer to decimal, do the math, come up with the final result. I just realized this is hidden. Huh. Do the work, come up with this number, and take this number back to the array form. There might be a way possible, like if there is a relationship between those two numbers and this number right here, I feel like I might be able to come up with a relationship right here. So to be able to think of this, I'm gonna try to add two normal binary numbers just by using the arrays, and I'm gonna apply similar logic to the Negabinary numbers. And I'm gonna see if the same logic applies, because if the same logic, because also think about how computers do their math. They don't convert the numbers to binary. They don't convert it to decimal. They just add it as binary numbers. So there is a process of adding binary numbers just by looking at the zeros and ones. So if I can simulate that process but take into account that I'm considering -2 as a base instead of binary. All right, so I'm going to try to do this example, then maybe we'll get to do some research, because I'm not exactly sure. So let's take, for example, the binary number 1101. This number in decimal is, that's power of 0, that's power of 1, power of 2, power of 3, and I have 1 plus 4 plus 8. That's 13. Then let's say we want to add it with the number 3, right? This is a 3. So I should get a 16. So how does binary numbers add? Well, we add it similar to how we add numbers in decimal, which is, I'll look at it as 1 plus 1, sorry about that, so 1 plus 1 is 2, but there is no 2 in binary, so I'll put a 0 and I'll carry a 1. And 1 plus 0 plus 1 is a 2, so I'll put a 0 and I'll carry another 1. And I have 1 plus 1 is 2 plus 0 is 2. There's no 2 in binary, so I'll put a 0 and I'll put a 1 right here. 1 plus 1 is 2. I'll do the same thing. But I add a 0, the 1 right here, but there's nothing underneath it, so I'll get this number. So is this 16? Well, let's look at it. Power of 0, power of 1, power of 2, power of 3, power of 4, and I only have a power of 4. That is 16. So I'm going to take the previous example that we just did with the Negabinary numbers. I don't know if I'm saying correctly. Negabinary numbers, and I'm going to see if I can apply the same binary addition logic to it. It's interesting to see if it will actually work. So what did I have? I have 18 as 10110. So I have 101. I have 10110, and that's 18. Then I had 11143. 11143. And their addition came out to 21. So let's try the same logic. 0 and 1, we get a 1. 1 and 1, we get a 0 and carry a 1. 1, 1, 1, we get a 3. So 3 in binary is 1, 1. So we have a 1 right here, and we carry a 1, and we get this number. Is that the same thing we got here? It's not. Here we got 10101. Here we got 11101. But it's close, so I can't help but think maybe there's a slight modification that we can take into account. So I'm gonna consider this one. We had a 3. 3 is 1, 1 in binary. So I'll put a 1, put another 1 here. So the straight up addition is not working. I'm curious, what is this binary number right here? What does this result mean? So I know this is a power of 4 right here. So I'm getting a 16, and a power of 3 is 8. But yeah, I'm gonna look at it as just a binary number. So I get 8, because we can do this in code very easily by adding 2 binary numbers. I get an 8, I get a 4, no 2, but I get a 1. So this equals to 29. The difference between those two numbers is 8. So if I can attain this result quickly and just subtract 8 from it, I'll get the answer that I want, which is 21. If I subtract 8, it'll be 1, 1, 1, 0, 1. That's 429. Now when I subtract an 8, the 8 is 0, 0, 1. So I'll get 1, 0, 0, 1, 1. All right, not even close. I feel like there should be a relationship using this addition. Okay, let's Let's research Negabinary numbers. All right, so the first link actually talks about how to add two numbers. Oh, and it talks about how to add them right away without converting to decimal. So kind of similar to what I was doing. Okay, Math World. All right, let's take a look at this one. You add them just like regular binary numbers, except the carry is negative, and you should be subtracted from each column instead of adding to it. There you go. So I guess that's the difference that we need to account for. So, okay, I'm only looking for the last one. Note that translates to 1 with positive as -1 regular numbers, 11 in Negabinary. For a more convoluted example, okay, the respective columns are negative on black. So in some situations, you can have a negative carry or you can have a positive carry. Is that what it means? You add them just like regular binary, except that the carry is negative and should be subtracted from each column. So here we have 1, all right, so that's a 1. Then we have 2 1s, so that's 0, 1, and the 1 is a carry right here. So -1, 0 plus 1 is 0, 1, 1 is 0, 1, and this one is a -1. So the -1 plus 0 is -1. How do we write the -1? So here it seems like you wrote it as 1. I'm using color red to signify a carry with negative value. For the last one, note that translates to 1 with positive black carry of 1, as -1 in regular numbers is 1, 1 in Negabinary. Oh, okay, so if we're dropping this -1 to the result, it has to be written in the Negabinary form, which is 1, 1, because the left one is -2 and the right one is 1, so -2 plus 1 is -1, which is this -1 right here. So I don't know why this one is written this way. All right, then maybe we could try an example. We can try an example. I feel like this might solve the problem. All right, let's go back to the notebook one more time. Okay. So We'll do the same example of the 18 and the 3. So we have an 8, we have a 3, and the 8 is given to us as 1, 0, 1, 1, 0, and the 3 is 1, 1, 1. All right, so 0 and 1 is 1. 1 and 1 is 2. 2 is 0, and this is a negative 1. So negative 1 plus 1 is 0. Plus 1 is 1, so we get a 1. The 0 goes down, and the 1 goes down, and this is equal. This is the same as previous answer. Okay, so this sounds pretty good. So let's do the example that's in the form that they showed us. This person, Arthur, is adding, I'm just copying them to my notebook, so I have 1, 0, 1, 1. I'm going to do the complicated example on the bottom so we get a good understanding of what's happening. So we have 1, 0, 1, 0, 1, 0. I have 1, 0, 1, 1, 0, 0, 1, 1, 0, 0. All right, so I'll switch to my notebook and let's see how we can do that. So 0, 0 is 0. We have a 1 right here. This is a 1, obviously. Then we have 1, 1. So this one is going to give us 2. Oh, we have to think of what 2 is in Negabinary numbers. So a 2 is written as 4 minus 2, and that's 1, 1, 0. Because a 0 is a 1, this one is a negative 2, and this one is a 4. No, that doesn't make sense. No, that's positive 2. Oh no, that we want it. We want positive 2. Yeah, we want positive 2. So a 2 is 0. And we have a 1, 1. Then the 1, 1 in Negabinary is negative 1. So the negative 1 is 1, and I still have another one right here. So we get 3. So 3 in Negabinary is 1, 1, 1, because this gave us, oh no, it's 1, 0, 1, because this one is a 4, and this one is a 1, so that's a 5 actually. I want a 3. How can I get a 3 in Negabinary? So I can do 5. Oh, I can do 6. The only negative numbers I can work with to subtract is negative 2 and negative 8. So I need a 3. I need a positive 3. I feel like I'm doing something wrong. This might be too complicated. So everything so far until here was correct. So let's look at the math right here. So 1 and a 1 will give us a 1. Oh, we were here. Yeah. So the 1 and a 1 will give us 2. 2 in Negabinary is 1, 1, 0. So I'll put a 0 here. I'll put a 1 here. So I got this right, but my assumption is that this is a 2, and 2 in Negabinary is 1, 1, 0. So I put a 0 here, but do these mean that they belong to it? Oh, okay. So the 1, 1 that I had is equal to -1, right? The 1, 1 is a -1. That's why this one is in red, because it's a -1. So -1 plus 0 plus 0 stays -1. So I put one of it here, and the other one turns into a positive 1. Okay. Let's go back to my notes. So this is a -1. So a -1 is 1, 1. So I'll go down and I'll write it as 1. And I have another one. This is a positive 1. So I'll get 3. This is the final number. I know I'm not doing any math anymore. So what's 3 in Negabinary? 3 is what did he have in the notes? 1, 1, 1. 1, 1, 1. 1, 1, 1. The first one is a 1, the second one is a -2, the one is a 4. 4, -2 is 2. Yeah, so 1, 1, 1 is a 3. So this is a 3. So we have 1, 1, 1. Okay. I feel like we need to do it one more time so we can sync it in. Because remember, this is the logic that we're going to have to start writing in code. This is going to be our solution. We literally got to the solution. Probably the best solution. This is how, I think this is how LeetCode expects us to write the answer. It should be this way. All right, let's do it one more time. So we have 0, 0, that's 0. 1, 0, that's 1. 1 in Negabinary is just 1. Then, and remember, we're doing everything in Negabinary. So if we have a 2, we have to think, how do we write 2 in Negabinary? So I have 0 and 1 is a 1, so that's a 1. Then we have 1 and 1. 1 and 1 will give us 2. 2 in Negabinary is 0, 1, 1. So this is a 0, and the 1, 1 is a -1. So we can imagine it as being -1. Then -1 is written 1, 1, so we add it with the zeros, we still get a -1. So the -1 is a 1 here. And and the carryover is a positive one. So only when we drop a negative number into the final result, what's left out becomes positive. And since it's a positive 1, it's positive 1 in Negabinary is just 1. So we get 1, 1 plus 2 plus 3, or 1 plus 1 plus 1 is 3. 3 in Negabinary is 4 minus 2 plus 1. That's 3 ones next to each other. Okay. So this is the logic. We need to think about how can we turn this into code. How can we turn this operation into code? So we definitely have to keep track of any remainder that we have. We have to consider if the arrays are smaller or larger than each other and pad it in case we needed to. So for example, here we need to pad these zeros, and probably we're going to have a loop that goes through each pair and adds them, and we keep track of a leftover or a carry-on, and keep track of a carry-on to the next level. Then we have to be able to track whether the carry-on is negative or positive. Okay, let's see if we can put together some pieces of logic. So the first thing is pad the smallest array with zeros. So we pad first. We know that each array is, both of them are the same size. Then we have loop through or from 0. Just do a little better. Loop x from 0. Oh no, we're not starting from 0. We're starting from the left. So we're gonna go from array 1 dot lengths minus 1 all the way to 0. All right. Then the first thing I want to do is I have two strings. The zeros and the ones are strings. So I can parse them to ints. So I can do array 1 x 0 and array 2. Oh, this should be x right here. And x, and this is int. I'm going to call it a, and this is an int. I'm going to call it b. I know there are numbers. I'll just perform those should be within the loop. So they should be a little indented like this. Okay, so I have two integers. They are only going to be zeros and ones because that's how the numbers are given to me. Then I have a carry. I need to be able to track a carry on. So I need a variable. I'm going to call it carry. And I'm going to set it to 0 for now. And here we'll start. So I know I want to add both these numbers. So I need to be able to say result of A plus B. Then let's think of the possible combinations of only A and B. Let's not consider the carry-on. So with A and B, we can have two zeros, 0 and a 1, 1 or a 0, and two ones. In three of these situations, I don't worry about the carry-on. I can just add them normally. And the third situation, which is 1, 1, I care about the carry-on. So maybe I need to have a separate piece of logic that says if A and B is more, or if result is equal to 2. But remember, I also have a carry-on. If I am in the middle of the array, I need to consider the carry-on along with the addition of both. And okay, now I'm going to increase the number of configurations or the number of situations I can handle. So I know I have two zeros, 1 and a 0 for A and B, 0 and a 1, and a 1, 1. Let's actually write it down. So let's have A, B, and I have carry. So A and B could be 0, 0. I can do 0, 1, 1, 0, and 1, 1. But the carry could be different. This is cases with carry of 0. So let's say the carry could be negative 1. And I have A and B. A is 0, 0, 0, 1, 1, 0, and 1, 1. So for these ones, negative 1, so this is a special case. If it's in, I'll get a negative 1. And the way I write a negative 1 is by writing a 1 and carrying a positive 1. So my carry-on becomes 1. When I'm here, I write a 0. My result is a 0. For this one, the same. For this one, my result is a 1. So this is a special case where I have to worry about the carry-on. So I need to be able to detect it. Then result right here. Then if I had, this is a normal addition, 1 doesn't matter, 1, then I get a 2, or I get a 1, 1. So this is where I'm going to have a positive carry. Or a 2, how do we write a 2 in Negabinary? A 2 is 0, 1, 1. Did we have an example of a 2 right here? So we had 1, 1, yeah. So the 2 is written as 0, 1, 1. So I need to be able to detect this one, because that's going to be written as a 0. And I'm going to carry, if it's written as a 0, because it's Negabinary, I'm going to carry 1, 1. That means I'm going to carry negative 1. That means my carry will be negative 1. So that's a situation I want to be able to detect, where the result of the addition is 2. I write a 0 and I carry a negative 1. Okay, so now I detected two cases where I need to do some special work other than regular addition with all the carry and the A and B. So another case for carry is when the carry is 1. 1, 1. And I have A and B. And I have 0, 0, 0, 1, 1, 0, and 1, 1. All right, so 1 and 2 zeros is a 1, so that's normal addition. This is going to be a 2 with a positive, if you remember from up there, or from this case right here. This is going to be, we're going to write the 2 as a 0, and I'm going to carry a negative 1. So I want to be able to detect this case, and the result here of the addition is 2. And the same with this one. And okay, so that's interesting case. Here we get 3. The way we write 3 is negabinary. We remember from, where was it? Anyway, where did I have it? We were calculating it together. Anyways, the way we write 3 is 1, 1, 1. So when I get a 3, I need to write a 1 and carry the 1, 1. And the 1, 1 is a negative 1. Or write a 1 and carry the 1, 1. 1, 1 is a negative 1 also. I can detect this case if the result equals 3. Here the result is negative 1. If it's negative 1, okay, I can't write this, so this is wrong. If the result is negative 1, what is negative 1 in negabinary? It's 1, 1, 1. So I need to write a 1 and carry oh no, the result of negative 1 in negabinary is written as how do we write negative 1? It's negative 2 plus 1, so it's 1, 1. So I write a 1 and I carry another 1. And the 1 on its own in negabinary is a positive 1. Okay, so kind of the logic is adding up. The logic is making sense. So I guess those are the cases that we need to worry about. There was that special case that was in this edition. I think I'm just gonna try to write the logic without accounting for this specific situation. And let's see how it works for some of the simple cases. So with this one, we have 3 special cases. The one right here, if I got a 2 for the result of my addition, if I got a 2 in negabinary is 0, 1, 1. So I'll put a 0, and I'll have a carry of -1 because the 1, 1 is a -1. So let me explain it right here. The 2 is equal to 1, 1, 0. So I'll put down the 0 and I'll carry the 1, 1. But the 1, 1 is a -1. So I can assign the carry variable to -1. Then in this case, when the result is -1, how do you write -1 in Negabinary? You write it with 1, 1. -1 is equal to 1, 1. We'll drop one of it to the result, just like here. And the one next to it, so we got 1, 1, we drop 1 to the result, and the other one goes to be the carry. But 1 on its own in Negabinary is equal to 1, +1. Okay, so we should be seeing the logic right here. Whatever left out, I evaluate it as a Negabinary number. Then right here, when I have a result of 3, the way we write 3 in Negabinary is 1, 1, 1. I drop 1, and what's left out is 1, 1, so that becomes the carry, which is equal to -1. Then, what did I have? Which case is this? The case for 2 should be the same as this one. We carry a -1. Can we have a case of 4? So let's think, what's the biggest amount a carry could be? It could be a 1, or it could be a 2. No, it cannot be a 2. It could be a 1, or it could be a -1, and it could be a 0. And we just covered all these cases, 1, -1, and a 0. All right, let's go back to our logic. So we gotta detect if the addition is equal to 2 with the carry, and if the addition is equal to -1, or if it's equal to 3, and we have to act accordingly. So I'm gonna add the carry right here. So now we did the full addition. Then I'm gonna detect if it's a 2. I'm gonna detect if it is else if the result is equal to a 3, and I need to detect if the result is equal to -1. And we have to assign a carry and write the result in each of these cases. So if it's a 2, if the result is 2, 2 in Negabinary is 1, 1, 0. So we'll add a 0 to the answer. I'm just going to do it this way. And answer dot add 0 as a string, right? Because they're expecting an array of strings. Then I'm going to assign the carry to be what's left of that 1, 1, 0, and what's left is the 1, 1, and 1, 1 in Negabinary is -1. So the carry will be equal to -1 right here. A 3, what's a 3 in Negabinary? A 3 is 1, 1, 1. So answer dot add a 1, and what's left is a 1 1, so the 1 1 is a -1. So if the result is a 2 and the result is 3, we add -1. So let's see, is that what we got here? If the result is a 2 and if the result is a 3, our carry is -1. Okay, fair. Then if the result is -1, what's -1 in negabinary? -1 in negabinary is 1 1. So we add to the answer a 1. And what's left out is a 1, and that's equal to a 1 in negabinary. So our carry is equal to 1. So in the case of -1, our carry is +1. So that should handle everything as far as until the last pair. Then we might run into a situation where after we add the last pair, let's say the last pair was a carry from the previous case, and we get a 3. So what should we do with that 3 for the last pair? We'll write it, and we'll have a carry on in the end. So this is the main loop, but probably after we finish the main loop, we should be able to see if is there any carry on left and deal with it and append it to the answer. So I think it's enough about writing notes. I think it's about time that we can start writing a solution. All right, so we'll go from here. So I'm going to start with a carry on. I'm going to assign it to 0. And I'm going to figure out the padding. So in JavaScript function, JavaScript is a very rich language, the functions that come with it. So they might have a function that is specialized in padding. So maybe we can do a quick lookup if there is such a function. If not, we'll just do it manually. So JavaScript array padding. There's a fill method. Okay. So it looks like the fill method does not add new elements. It just fill, like we have 1 through 4, and the output was the same size. So we want something to change the size. Pad start. Okay, but that's only for a string. We can append arrays if we want to. Let's see, array padding, concat array.length.fill. Oh, we can create it this way, an array of a certain size, then fill it with the same number, then slice. I think the slice here is to make a new one. Okay, this seems like a reasonable solution. So let's look into array constructor JavaScript. So this is the array constructor. We get an array length and all that. All right, so maybe we can try something like that. So, I'm gonna have, I need to be able to know which one is the smaller array. let's do small array as a variable. We'll write it in a different way. Small array, and we have large array. Then if array1 dot length is larger than array2 dot length, that means array1 is bigger, so large array equals array1. If that wasn't the case, large array equal to array2. So what this if method is doing is find largest array. Alright, so now we found the largest array. Let's pad the smaller array. So pad smaller array. Always leave comments in your code. So small array equals to and you, can I do it this way? Array of size. What's this? How many elements are we going to pad it with? Well, we can just do the difference in size. So we'll do large array dot length minus small array dot length. So that will give us the difference of elements. So that's how many elements we're going to create. Then fill this array. This maybe. Then we have to fill the array. So JavaScript fill. Fill with 0 from position 2 to position 4. From position 1. Okay. So I could fill the whole array with zeros like this. Then I have an array, it's an array of 0, it's what's missing, so I can concat with small array. So now both arrays have the same size. Can I assert? I've never done assertions in JavaScript, but we can try. Oh, it's a node. Console assert. Console assert. Okay, let's use console assert. I don't know if we can use it with leetcode. I've never used I don't do leetcode a lot. So console.assert. I want small array dot length should be equal to large array dot length. Now, if it wasn't the case, I need to say it's not padded correctly. That's probably the problem. Then now we haven't padded correctly, so let's loop through the pairs. So let I starts from, again we have to start from the end, so small array dot length minus 1. We have I have to be bigger or equal to 0 because we want to go all the way to the beginning. Then what else? What are we going to do here? We're going to decrement I. And I just remembered it will be good if we had an answer array that is ready for us to start padding or appending the result into it. And also remember, we have to make sure that the most significant digits are on the left, so we have to insert from the head of the, or we have to insert in front of the array. We can't append it to the array. We have to insert it at the beginning each time and shift everything. So we make sure that we have that taken care of. So here we'll make sure to add the numbers correctly. So we'll do let a equals small array I. And the way we parse an integer in JavaScript is by using this function called parse int. And we're going to do the same thing for b, but we're going to grab it from the large array. Then we're going to have a result variable where it's e plus a plus b plus carry. So now we're going to test. Let me get that moving out of there a little bit. Get my face moving out of there. Okay, so now we'll test the special situations that the carry will be. So if the result will be. So if the result is equal to 2, that's one case. If the result, we're going to use else if. The reason we want to use else if here is that we only want one of these cases to be true. If we separated the if statements without this way, if we separated the if statements this way, it's whatever the case could be. If there is maybe some internal bug, we might get two cases running. But in our specific case, it might not be a big problem because we're asking for different things. So if one runs, that means for sure the other one will not run. But I would probably prefer an else if. The reason it's better is that once maybe the first case runs, it won't evaluate the second one. So we're saving some CPU cycles that will otherwise be run if there is multiple if statement blocks rather than one connected else if blocks. Because this way, let's say the result was a 2, it will come in, it will evaluate the first one, it will run this block of code, and it doesn't care about the rest because it knows it's an else if blocks. But if it was if blocks, it will actually execute the comparison. And why not be a little more efficient, although the logic could be good. So that's the second case that we'll worry about. Then the last else if, it will be if result is equal to 1. So in each of these cases, we're going to add to the answer array, and we're going to specify the carry on. So the way we can add to the front of the array, let's see the array methods in JavaScript. So we have array push, if I set push, maybe I'll be able to spot the other methods. So we have push, and what's nice is you can look at C also, so anything related to adding to an array will show up here. So I think shift will add to the move, removes the, this shift method removes the first element from the array, returns the move. Okay, so shift is from getting. Unshift, what about unshift? The unshift method adds one or more to the beginning of the array. So we want the unshift method. See here, they're adding 4 and a 5, so the 4 and a 5 appears in the beginning. So we'll use unshift. So if the result is 2, we have to answer the unshift, and we're going to add some type of string. And I know, then I'm going to do carry, and I'm going to specify it to be something. I know I'm going to run this code every time. So if it's a 2, again, what's the negabinary of a 2? The negabinary of a 2 is a 1, 1. So I'm going to drop the first one and leave the second one. The second one in negabinary is just 1 decimal, so I'm going to, my carry is 1. The second case is if it's a 3, 3 in negabinary is 1, 1, 1. And feel free to pause and just do your math on your own. We did these on the notes, so I'm kind of stuck to my head. So if the 3 is 1, 1, 1, I'm going to drop the first one, so I'll add it to the answer. And what's left is 1, 1. 1, 1 in negabinary is -1 in decimal, so my carry will be -1. Then if the result is a 1, oh, I guess I shouldn't worry about result 1. If my result is -1, my result is -1, that means it's a -1 in negabinary. -1 in negabinary is a 1, 1. I think we made a mistake. Okay, here. Our mistake is right here. So I'm going to leave some comments so I'll be able to pay attention also. So 2 in negabinary is 1, 1, 0. And the way we can specify base, I believe, it's this way. Base is -2. So I'll actually need to append a 0 right here. And the 1, 1 that we have, they will become 1, 1 in negabinary is -1. So that will be a -1. And if our result is 3, so 3, we'll write it in also same notation. So 3 decimal will give us 3 in decimal will equal to 1, 1, 1 in negabinary. So I'm going to take one of the ones, and the other 2 ones will be -1. Then if I have a -1, comment it right here. So -1 of base 10 in decimal will be equal to 1, 1 in negabinary. So in this case, I'll take the 1, and the other one will just be equal to 1. And we're almost done. So in the end, I need to check the carry. And to check the carry, I just need to understand what's the carry value and add it as numbers. I'm curious to see what's the result of this code. Let's run the code. Oh God. Can I remember? If we run the code, this is a problem. So padding, I'm going to make it equal to the new array, and I'm going to take padding array this way. I'm going to fill it, concat. Let's see if this works. New array, large array. What's the problem here? Cannot read property length. Oh, I never assigned the small array. So if the large array is array 1, the small array is array 2. If the large array is array 2, that means the small array is array 1. Concat is not a function. So JavaScript concat array. Okay, so it looks like it might have, should be fine. What about fill? Array fill. Fill should return an array, it returns a modified array. So I can call concat. Padding is an array. I fill it with zeros, and I did that. Let's concat. Run it. Okay, so we had a problem with the, we probably have an off by 1 error. So the nice thing about these is when you don't know exactly, you don't want to think about it, you can just do an assert, it'll catch the error, then you'll think about it better. So actually what we can do right here is so let's think about it maybe. Let's say the large one had 5 and the small one had 3. And I do 5 minus 3, I get 2. 2 is the padding required. 2 elements is the padding, so the size of the padding should be 2. So the way I have it here should be fine. What if we try to print small array dot length? I run it. So small array dot length is 5. And I think they were trying to run this example, so I have 1, 2, 3, 4, 5. Oh, that's the problem right here. Because the math should be okay. We just subtracted 2 numbers. Oh, God. Okay, it looks like we iterated once. What could be the problem? Let's look at it. The I is the length minus 1, and I decrement it. Could it be the unshift method? No. What's wrong with this code? Let's see if processing one pair, that's run code. Okay, it's actually iterating through all of them. Our output is still 0. Oh, I think unshift should take I can take elements. I want to log the answer. At every step. Okay, interesting. The answer never changes. I wonder if I have to reset any variables at the end of the loop. Result. Okay, so the answer array is not changing. I want to also maybe log AB and result. Okay. Okay, so they're getting changed. Oh, that's the problem. We ignored the trivial case, which is, what if result is none of these numbers? That means it will be a 0 or a 1. In this case, we should just answer on shift and add the result as a string. Now our carry will be a 0. Now the test case worked. Now I don't need to log. And I made sure I come to this case. I don't like how these blocks look. Okay, so now in the end we can handle the carry. So as we remember, the carry could be 1, could be a -1, only a -1. So based on these numbers, we can add we can append to the end of the answer, to the end of the answer, the beginning of the answer, right? So we have to check what the carry is. If carry is equal to 1, and do answer shift, and if it's a 1, I can just unshift a 1, and the 1 will be enough. But if it was a -1, -1 in negabinary is 1, 1. So I need to append that 1, 1 to the end of the answer. So that's a 1, and that's another 1. If it's a 0, I don't care, and that should be it. That should take care of it. So here we're counting for left over carry, and we're adding it to the answer. Let's submit the code. Let's see if we're confident enough of submitting the whole code. Okay, so we failed at one of the cases. It looks like we're adding 1 and -1. And 1 and -1 is 0. So we got 2 zeros. that means we have the right answer. It's just it did not like it because it wanted it as 1, 0. So how can we handle this case? So if it's a 0, or I think the issue is here is that no, we can't have any leading zeros. Can we get rid of leading zeros? Yeah. So for such solution, you can think of another case that we can run into of adding 8 and -8. We're going to get a 0, but we're going to get multiple zeros at once. And what if we had a case where we had an actual number but quite a bit of leading zeros? How can we take care of that? I need to be able to detect if the first n elements of an array is 0 and delete them. Let's see if there is anything in the array that will help us. Reduce right. Okay. No, not the reduce function. I don't want to filter. I can keep removing from the front until I don't have any more ones. That might be possible. Using the shift method. Where is the shift method? Right here. So the shift method should take you give you the first element, right? So getting rid of leading zeros. Remove leading zeros. So here I'm going to have a while loop. I'm going to say while the first element of an answer equals 0 and the length of the answer is more than 1. If those conditions are true, just unshift or shift, answer.shift. Now I don't want to grab it, so I don't want to grab the result of shift. It can go away. Succeeded here. Okay, the solution worked. So the memory usage seems to be low. I don't know, I think there was a way where we can look at the actual details. editor, shortcuts, colon, problems, details. There you go. So we have to keep in mind that the performance indicators of these solutions are not very accurate. Don't quote me on that. It could be very accurate, but I've had a couple situations where I run a solution multiple times, although it's the same solution, and it gives me multiple runtimes or multiple duration for the solution, although it's the same code. So that's why I say it's sometimes not that accurate. So it looks like there's people that got it. There's submissions that are pretty quick. Our submission is a little slow. Accepted solutions. All right, so we know we have a working solution at this point. Maybe we can start optimizing a little bit. Maybe instead of adding a whole thing for the padding, because this might be an expensive operation to create an array and fill it and concatenate it to another array. Maybe we can do this work, detect that an array is smaller, and fill like an A or a B element with just a 0. So what we can do is get rid of this for now and detect if this element does not exist. If this equals undefined, that means assign a 0 to B. Undefined. And if this one is undefined, assign a 0 to B. So here what we're saying is, like, if this element does not exist, that means it sits in an array that could be smaller than the bigger one. Assign a 0 to A, because that means there's no number. I'm just going to pad it. Instead of doing the padding initially, I'll do it right away, and I'll have a 0 and all that. Also here, since we're going by the smaller array, we can do a quick size, a quick maximum thing. So we can get rid of these variables, and we can have a variable that says biggest size. I can do math.max of array1.length and array2.length. JavaScript math.max, that's a function, right? Yes, it is a function. So I have the biggest size. So the biggest size -1 is going to give me the correct number of loops. And here I got rid of the small and big arrays. So this solution might be a little better. Oh, my bad. The ternary expressions are written with a question mark in the beginning. They call them ternary expressions. Submit. We forgot the arrays. Submit the solution again. That's wrong. So let's see what's the problem now. We're creating an instant pad right here. And 0 parse int. We add them the carry. We got an extra looks like the math might be completely wrong. Oh, I see. So the problem here is that we're starting from the end of the array, not the beginning. So when we start from the end, we're going to first encounter the undefined, and we're going to replace it with a 0. Then once I goes down, we're going to start seeing numbers in the smaller array. So that's going to change what numbers are we dealing with. So to deal with this problem, one solution could be reversing the arrays and going through them from the beginning. So this will be this way, the reverse. Reverse might also be an expensive operation. That I don't know if it exists in the first place. Okay, so there is such thing as a reverse method, I guess. Yeah, there is a reverse method. Let's see if it's any good. So biggest size. Or here, I should be just shy of the biggest number. And we're going to increment I. Oh, here we're trying to declare. Okay, so this solution is actually a little worse. Let's see if we get different results if we submit it again. Almost the same results. It's also bad. Or we can do better. We might be able to do better. We should be able to do better. Maybe instead of reversing, and we can still traverse it backwards, we can have a while loop that fills the smaller one. Okay, so I need to figure out the smaller array. That means I'm going to have a small array variable. And small array variables equal to array1. We'll do a ternary expression. Length. If it's bigger than array2 that length, that means array2 is the smallest, or otherwise give me array1. Alright, so we have smallest array. Now we can do while smallest array dot length does not equal biggest size. I'm going to keep on shifting as 0. Small array dot unshift 0. So this way I'll create the padding without constructing new arrays and concatenating, because the constructing new arrays might be a very expensive operation. So this way, if I have everything padded, I could delete these and I can parse safely and I can traverse from the end. Okay, so see here we got our solution is a little faster, almost the same memory. So this is still we're using n memory right here because our solution grows with we're creating a new array and we're filling it, and this array is going to be as big as the numbers they come in. So what might be interesting is if we're able to do it in place where the result, we can replace the results in one of the input arrays. So we don't have to use some extra space. So that's one option. One area we can improve is that. All right, I think I'm going to leave the solution at this. This is the first video that I make, so I hope that it was helpful. I hope the notes were helpful. We're barely over 2 hours. I don't know if I'm going to upload this to YouTube or not. This is my first video. But if it's uploaded, please leave a comment. Let me know how things could be better. I researched quite a bit to figure out how can I include my iPad Pro note-taking into the actual video while including my face at the same time. So let me know if this setup is good, if it's bad, if it could be better. And let me know if the value of me discovering how the solution is good to you guys. And so yeah, leave me a comment. I'll probably make more of these because I will be prepping for some interviews. Take care.